In 1945, the station master at the Benton Harbor, Michigan Railroad Depot called a local businessman, Howard Anthony. 4 boxcars of war surplus electronics had arrived at the freight yard. Storage fees would begin accumulating in 7 days. Anthony did not remember placing the bid. He had no warehouse prepared for that volume and no catalog of buyers waiting for the parts. What he had was a problem. But the way he solved that problem accidentally built one of the most important industrial training programs in 20th century America. 47 years later, the country decided it no longer wanted that program. The Heath Company did not begin in electronics. It began in the sky. In 1926, a Chicago aviator named Edward Bayard Heath founded the Heath Airplane Company on a single commercial idea. He believed ordinary Americans could assemble their own aircraft at home if the parts were well designed and the instructions were clear. His most successful product was the Heath Parasol, a single-seat plane with a high-mounted wing. For a few years, parasols took off from farm fields and dirt strips across the Midwest, built in barns and garages by men who had never worked in an aircraft factory. The experiment ended in 1931. Edward Heath climbed into a prototype he was testing outside Chicago. The aircraft went down. He was killed on impact. The company limped through the early years of the Great Depression and slid into bankruptcy. In 1935, a businessman named Howard Anthony bought the remains for almost nothing. He moved operations to Benton Harbor, a small industrial town on the eastern shore of Lake Michigan. Through the rest of the decade, Anthony kept the company alive, making aircraft components and serving the slow trickle of surviving parasol owners who still needed parts. When the United States entered the Second World War, the federal government needed anything with an aviation contract. The Heath Company took on military subcontract work. Over the next 4 years, the small factory was producing aircraft components, including electronic equipment for military planes. That detail looked minor at the time. It changed the trajectory of the company and eventually the trajectory of American technical education. In the summer of 1945, Japan surrendered. The defense plants began shutting down. The United States government was left holding warehouses full of radios, test equipment, vacuum tubes, and radar components that no one needed anymore. All of it was auctioned off in enormous quantities at prices that reflected the fact that the alternative was scrap metal. Somewhere in that auction, Howard Anthony placed a bid, which brings us back to the railroad boxcars. Anthony, by most accounts, had underestimated the volume. When the station master called, he was looking at more electronic components than his Benton Harbor facility could absorb. He called in favors, friends, neighbors, acquaintances with barns and empty garages. Parts were moved by truck and stacked in every dry space within driving distance. The inventory was sorted piece by piece over the following months. Buried in that pile, the Heath Company found a quantity of 5 BP-1 cathode ray tubes. These were 5-inch display tubes that had been built for radar sets during the war. In July of 1947, Anthony's team released a product designed around them, a working oscilloscope, sold as a kit with every component packaged and labeled, and a booklet explaining how to assemble it. The price was $39.50. A factory-built oscilloscope from a name like Tektronix or Dumont cost several $100s. Serious laboratory models cost several thousand. The Heathkit was a fraction of that, and the only trade-off was that the buyer had to build it himself. The timing could not have been better. Across the country, hundreds of thousands of veterans were enrolling in engineering programs on the GI Bill. They had picked up electronics in the Army Signal Corps, the Navy radio rooms, and the aircraft maintenance depots. They needed test equipment they could afford, and now there was a company selling it to them. The O1 oscilloscope sold out. then it sold out again. What Heathkit did next was more important than the price point. The instruction manuals were not assembly guides. They were courses in electronics. Every manual included fold-out pictorial diagrams showing the exact physical location of every resistor, capacitor, and tube on the chassis. Each step was written for someone with no prior experience. Each major section explained why certain components had been chosen, what they did in the circuit, and how to test them if something went wrong. Troubleshooting tables covered dozens of failure modes. A college student who built a Heathkit oscilloscope in 1950 did not simply end up with an oscilloscope. He ended up understanding how an oscilloscope worked. He had touched every part. He had soldered every connection. When a component failed a year later, he could open the chassis and find the problem without calling a repairman. The instruction manuals were an industrial pedagogy. They trained a generation of technicians, engineers, and hobbyists at a scale no formal school system could match, and the company treated education as a line of business. By the 1970s, Heathkit Educational Systems was selling formal training courses to high schools, community colleges, and military training commands across the country. There were courses in electronics, fundamentals, digital logic, microwave theory, and eventually microprocessor programming. The product line expanded in every direction that amateur electronics could go. In 1953, the company entered amateur radio with the AT1 transmitter kit. This opened a door that would define Heathkit's cultural footprint. Ham radio operators were natural customers. They were technical, curious, and willing to spend weeks assembling a transceiver if the result performed as well as a factory-built unit at half the cost. The SB series transceivers, released across the 1960s and the 1970s, became legendary among operators. The SB-101 sold in tens of thousands of units. Building one took well over 100 hours of careful soldering and alignment. When a ham operator made their first contact on a radio they had built from a cardboard box of parts, the feeling was its own reward. Thousands of operators alive today still remember the night they did it. Alongside the ham radio division, Heathkit expanded into color television kits, high-fidelity audio, weather stations, clocks, electronic organs, and eventually personal computers. The annual catalog became an object in its own right. Subscribers waited for each new issue. Dog-eared copies circulated through family basements and workshops for decades. The company's peak was not a single year, but a stretch that ran roughly from 1965 to 1978. During that period, Heathkit did not merely sell electronics. It defined a particular American relationship with technology. The relationship assumed a capable adult could understand the machines in his home, that he was entitled to open them, that he should be able to fix them, and that the manufacturer had an obligation to explain how they worked. That assumption is not a given. It is a cultural artifact, and it was about to come apart. Three forces converged on Heathkit in the late 1970s, and the company could not absorb any of them. The first was a manufacturing shift. Through-hole components, the kind a human could solder with a pencil tip iron, were being replaced by surface mount technology. Surface mount parts were tiny, often smaller than a grain of rice, and they were designed to be placed by automated machines. They were not designed to be hand-soldered by a hobbyist in a basement. The industry was moving toward a form factor that made kit building physically impossible for most buyers. The second force was price. In the 1950s and the 1960s, building a Heathkit saved significant money over buying a factory equivalent. By the early 1980s, mass production had made pre-built consumer electronics cheap. A Japanese stereo receiver that would have cost $300 as a kit could now be bought assembled in a department store for half that. The economic incentive that had driven a generation of buyers into Heathkit's catalog was gone. The third force was Zenith. In 1979, Zenith Electronics acquired the Heath Company. On paper, the deal made sense. Zenith had distribution and capital. Heath had a valuable brand and a loyal customer base. But Zenith's interest was not in kits. Zenith wanted the engineering team that had been developing the H8 and H11 personal computers, and it wanted a way into the business computer market. Within 2 years, the computer division was renamed Zenith Data Systems. It sold pre-built machines to corporate and government buyers. The kit business became a smaller and smaller division inside a larger company focused on something else. Through the 1980s, the catalog got thinner. Product lines were quietly retired. Veterans of the company watched the contraction in real time. In 1992, after 45 years of continuous operation, Zenith announced that the Heathkit electronic kit business was being discontinued. A company closing is not usually a historical event. Companies close all the time. What made the end of Heathkit different is what closed with it. For 45 years, a person in the United States who wanted to understand how a radio, a television, or a computer actually worked had a clear path to that understanding. He could pick up a Heathkit catalog, order a kit at a price he could afford, and spend the next several weeks building a piece of equipment that taught him its own operation as he assembled it. When he finished, he owned a tool and he owned a skill. The skill was transferable. The same hands that built a shortwave receiver could diagnose a failing television, troubleshoot an automobile ignition, or wire a home for a new circuit. That path is gone. The technology in the average American home today is not repairable by its owner. It is not understandable by its owner. The components are too small to see without magnification. The schematics are proprietary, and the firmware is locked. When a device fails, the economic answer is to throw it away and buy a new one. The manufacturer prefers it that way. The regulations often enforce it. This is what the right to repair movement has been arguing for almost 2 decades now, with limited success. The argument is not really about fixing a toaster, it is about a deeper question. Who is allowed to understand the machines that run a modern life? In 1947, the answer was almost anyone willing to spend $39 and a few evenings at a workbench. Today, the answer is a licensed technician working for the manufacturer under a contract that prohibits him from showing you what he is doing. The difference between those two answers is the Heathkit era. The boxcars arrived in 1945. The doors closed in 1992. In between, millions of Americans learned a set of skills that the country has not replaced and, in many respects, no longer permits. That is the part of the story that goes unspoken in most obituaries of the company. Heathkit did not die because it failed. It died because the kind of customer it required, a citizen who assumed he had the right to open his own equipment, was being phased out of the economy. The 5 BP-1 tubes that started everything were surplus because the war was over. In 1945, Howard Anthony saw them as a storage problem. He solved that problem by putting them in the hands of American veterans who had learned to use them in uniform. What he built over the next 4 decades was not a catalog. It was an infrastructure of technical literacy. That infrastructure is not something a private company can rebuild on its own. It required a particular moment in American industrial history, and that moment has passed. The question worth asking is whether anything like it can be built again, and who stands to benefit if it never is.